So 5.1 is about angles, and so we in the notes talked about acute angles, which are less than 90 degrees, right angles, which are 90 degrees, and then obtuse angles, which are angles that are between 90 and 180 degrees, which hopefully all of that's a refresher of geometry. As far as quadrants, we've got quadrant 1's top right, quadrant 2 top left, quadrant 3 bottom left, quadrant 4 bottom right. The quadrantial angles are basically, they're in a standard position, meaning they're going to be touching the x-axis. And there's different little like formulas as far as finding those, but there's not really anything that we're going to be doing specifically with that. And then coterminal angles, where we're adding 360 or subtracting 360 degrees when we get into working with radians, which isn't in this section, but it's another form of measuring angles. But when we get into that, we would be doing plus or minus 2 pi also. But the big thing in this section is degrees, minutes, and seconds. So typically when I hear that, I think of like the latitude and longitude lines. I don't know if you've ever really looked at like a map that says like, oh, we're at such and such a longitude or latitude or whatever. I don't even know. Anyways, I'm not good with geography either, so just bear with me. But they have like lines on there and it tells you like how many degrees like north or whatever I think it is of the equator. I don't know. Don't quote me on that. That's more of a Miss Greer question, not me. But anyways, we can figure out what that is as like in like the degrees, the minutes, and the seconds. And so we're going to be converting minutes and seconds into degrees, which basically gives us a decimal value. So yeah, anyways, we'll just jump right in. So the first ones, basically, which you're going to be like the first one when I tell you the problem number, and you're going to be like, I don't think that's the first problem. But it's problem 54, the stuff before that. One is just a review of geometry, and two, you don't really need it moving forward, so we're not going to do it. I try to pick out the stuff that you need, that if you go on to pre-cal or calculus or whatever in the future, you need this stuff. So, anyways, so that being said, number 54 is 82 degrees, 30 minutes. So minutes are denoted with like an apostrophe, and then seconds, I'm going to say it looks like quotations, it's a double apostrophe, but anyways, that's what it looks like. So they want us to convert the measure to decimal degrees, round to the nearest thousandth of a degree, if it doesn't like automatically cut off before that. So basically we take the 82 degrees, just gets copied down. Then we add, this is 30 minutes, so there are just like minutes in an hour. There's 60 minutes in a degree, so we take this and we do 30 divided by 60. It's not going to do it for me. My iPad was doing the thing where it like calculates. It was actually working the other day in another class, like doing trig functions. I was like, oh, this is fun. Anyways, so obviously 30 divided by 60 is 0.5, so this one just comes out to be 82.5 degrees. Oh, now you want to work. Okay. Anyways, but that would be the answer to that one. If we had, let's see, obviously that one I kind of just knew off the top of my head, but let's say it was like 58, where it is negative 70 degrees, 48 minutes. We set this one up, negative 70 degrees. Now, this one's a little bit more, like, because it's negative, when I put the adding thing, like, it's going to be negative 70 point something. It's not going to, like, take that number away from. So it's a little bit misleading. So I'm just going to wait and not write the plus sign on this one, just so it's a little less confusing as far as that goes. And then we've got 48 over 60, which obviously I can reduce this down and I can probably figure out what it is, you know. But normally we would need to just type in 48 divided by 60 or whatever the number is. And In this case, it's 0.8. So this would be negative 70.8 degrees. Okay, you're not doing what you're supposed to do. There we go.
The minutes always going to be over 60.
Yeah, the minutes will be, and then seconds are over 3,600. So you can think of it like how many minutes are in an hour? 60. How many seconds are in an hour? Or how many seconds are in a minute?
6.
And then how many minutes are in an hour? So 60 times 60 is 3,600. So that's where that number's coming from. Technically, like, the other way that we can do this kind of stuff is we can actually, like, do it by converting first to minutes, and then it wants us to convert to degrees. But I just think that that's such a longer, like, so much of a longer process when I could literally just do whatever the seconds are divided by 3,600. Just makes it a little bit faster. Let's see, 60, 38 degrees, 42 minutes, 18 seconds. It's coming down. All right, so I've got 38 plus, this one's minutes, so 42 over 60, plus 18 over 3,600. So you can either type these things in individually and do like 42 divided by 60, do 18 divided by 3,600, and then add them all together. Or I think I may have shown you all this little trick thing before, but if I wanted to type everything in as like one unit without having to like do piece by piece, I can do 38 plus, and then I can do, if you hit the alpha button, which is up here, and then y equals, it brings up n over d, which is to do a fraction. So I can do 42 over 60, and then I can arrow over plus alpha y equals, choose the fraction, 18 over 3,600. And so I have it all typed in as one thing, just like it looks on my paper. And when I do it, okay, well, good teaching moment here. It decided that it was going to make it a fraction. So obviously that didn't help me a whole lot, right? So what I can do though, and it probably did that because since I typed in fractions, it probably assumed I wanted fractions. But if you hit math over here, you'll notice I've always said that this is a dart. I don't know. My teacher called it dart frac or whatever. So we can take a decimal number, and if we hit that, it'll turn into a fraction. But if I have a fraction and I want it turned into a decimal, I can choose option 2 here, this dart decimal thing here. And it takes the answer that I had, and it's going to turn it into a decimal, and we get 38.705. So just another thing about how to use your calculator in case you didn't know about all of that. I used to tell people I'd help them on the SAT, whatever, ACT, but since they put the SAT online, there's a calculator provided for you. Some people, I don't know how to use that calculator, so I was never taught how to use Desmos, but I would like my tried and true, but some people just prefer to use the one on there now. But anyways, that's how you would do that. See, one more of those. 64, 165 degrees, 51 minutes, and 9 seconds. And I don't really know why they write it as 09. I'm assuming it's just a notation thing. The 0 in front. That was thunder. We were convinced earlier when the trash truck came that it was thunder, and then we were like, wait, that's not thunder.
No.
That, in fact, was, though. Power outage?
Oh.
I'm just kidding. Because I think if we miss any more school, we're going to start having to make it up. So, maybe not. Last time we had that power outage, the power literally, as we dismissed everybody, came back on.
Yeah.
It was so funny.
Yeah.
It's like, that's a new one. All right, so we've got 165 plus 51 over 60 plus 9 over 3,600. So I'm going to do it just like I did the last one. It's probably going to turn it into a fraction again. Maybe not. Unfortunately, they can't read your mind to know that you don't want it in a fraction. So, yep, it sure enough did it again. Math, start decimal. And when we do that, so it gives us 165.8525, but the instruction said to round to the nearest thousandth of a degree, so I'm going to convert this, or round it rather, to 165.853 degrees. It's going to be fun when we go to chapel in 20 minutes. Fascinating. All right. Find the angle of least positive measure not equal to the given measure that is coterminal. So on these ones, 78, it's 86 degrees. So they want, now I'm going to tell you, most textbooks, when they ask you to find the coterminal angles, they want you to find one negative one and one positive one. And so this book doesn't do that. They only want the positive one. Just know that if I added or subtracted 360 degrees, and I could do that 100 times, like it doesn't matter. They're all going to be coterminal with the initial angle that I'm given. But since they want a positive one, if I subtract 360 degrees, I can see because this number is less than 360 that I'm going to end up with a negative. So I know that I need to add 360 degrees to this one. So we just do 86 plus 360. This is where I should turn this function back on because it will work for this. Maybe. Let me try it again. What? I'm telling you, it was working the other day and it was super cool. No, that's not the number. What? Let me just rewrite it. It's fun when it works. 86 degrees plus 360 degrees. And then I don't have to get out my calculator. There we go. Solve. 446 degrees. It was solving trig functions the other day. Everybody was like, what is that, an iPad? I need to go get one. I was like, I mean, yeah, it works for trig functions apparently, but it doesn't work for anything else. It hasn't worked very well. That was like basic math, and that's about it. So anyway, so I added 360 to that one. 82 is negative 98 degrees. So we'd have negative 98. I know to get positive, I'm going to have to add 360, so plus 360 degrees. 262 degrees. Somebody the other day tried to tell me that looked like my handwriting. I was like, oh.
Yeah, that's what I thought it was originally. It's kind of an odd font.
Yeah. I mean, some of the numbers I guess you could say kind of do, but like, I don't write my 4s like that.
Yeah, the sixes look very similar.
Yeah. I was like, I don't know. It was just funny. They were like, it can even write in your handwriting. I was like, what? I don't know. 90 is 699 degrees. So they want the least positive measure. Okay, so that means obviously I could add 360 to this. It's still going to be an angle that's coterminal, but it's not the least positive, which is what they're asking for. Now, I'm going to tell you, typically on a quiz or a test, I'm going to ask you to just find a coterminal angle. The way that you go about that, you just need to get to one of them. I may ask you to find a positive and a negative one, where you would just need to subtract 360 until you get to a negative number. it doesn't really matter. So just be aware of that I may kind of shift the instructions just a little bit, but if you can find one coterminal angle, you should be able to find 100 of them. I mean, it's not a hard process. So I'm going to do 699 degrees minus 360 degrees. Nope. Okay, fantastic. Which is 339 degrees. So that would be my answer on that one. Now it decides it wants to do something. So obviously this number is less than 360, so that's how I know this is the least positive one. But number 92 is 1,000 degrees. So I'm going to subtract 360. Please work. Okay. And I get 640 degrees. This number is still bigger than 360, so based on what the book is asking for, I need to subtract 360 again. So 640 degrees minus 360 degrees. $280 degrees. Now that's the least positive one that I could have. So that one would be my answer. Now, if I just ask you to find a coterminal angle, you could stop here. If I wanted a negative one, I could subtract 360 again. Pretty sure I just saw lightning. I could subtract 360 again, and it would give me a negative one. So just be aware of that. One last thing I'm just going to show you, and I may give you one like this one just so that you can see it. But these ones say, write an expression that generates all angles coterminal with each angle, let n represent any integer. So basically they're telling us what our variable is going to be. So for problem 104, and this is where you can be glad that you don't have to do all the problems because there's 130 problems in this section. 104 is 225 degrees. And we want to basically write an equation that would give us all coterminal angles. So the way we do this is we would do 225 degrees plus 360 degrees, but I want all of them. This only gives me one of them, right? If I add 360, then I'm going to get whatever the next angle is. 585 or whatever. But if I want this to be all angles that are coterminal with 225, then I'm going to also multiply this by n. Okay, not just because they told me to use the variable n. So if I plugged in 50 for n, I could find the 50th angle that is coterminal with 225. If I was like, well, I want the fourth negative one, I could plug in -4 for n and solve it, and I would get the fourth negative one. Okay, so that's all that's wanting you to see, is that basically I can keep doing it over and over again, and I get all these coterminal angles. So nothing super, super crazy with that, but any questions on any of this? All right, problems then. It's not a lot. 55, 59, 81, 85, 91, and 103. So, kind of a short section. We'll plan to start 5.2 tomorrow, and then if we need to go into Monday with it, we will. So.